There we go. All right. So our speaker today is Randolph West, and their pronouns are they and them. I have to admit, I've seen Randolph around, but I don't know them very well. Their bio is impressive. They're a data platform MVP, which is hard to get, and been working with SQL Server over 25 years and have an impressive sheet full of speaking engagements, blog posts, and community involvement. And you go through and you look at that, and it's easy to see where the MVP award came from. But what you may not know about Randolph is one of a very small group of people that you'll see present to a SQL Server users group, and also has an impressive IMDb page with references both in front of and behind the camera. And in addition to movies, television, and voice acting, they've acted and directed stage productions as well. So it's the full package. Today, they're going to talk about the changing landscape in database administration and what that means to a DBA in our modern era. But maybe we can convince them to give some pointers on how in the world they fit so much into the same 24 hours that we all have to work with. So thank you so much for being here today, Randolph. I'm going to turn the time over to you. But I do have to say one more thing. I love, love, love your blog post about how floats are absolutely the best data type for financial data, and I could not agree with you more. That was just awesome, and it was very well put. So without further ado, Randolph West.
Thank you, Chad. That was an incredible introduction, and frankly, I'm a little embarrassed because I think you misread the float blog post. What I said is my second favorite data type for storing financial data. My favorite is SQL variant, and I just wanted to make that clear. In all seriousness, the only reason I managed to get all those things done is because I don't do all of them very well, and I don't sleep. So let's see how this goes, right? I'm just going to share my screen, which is the fun part of these virtual events, while somebody's staring at the camera like this while they're looking for their thing. And hopefully, I'm going to open the chat window here as well, because I'm going to encourage you to all ask questions. You can do it through the chat, or you can do it through our moderator, who I believe is one of the two people who are co-hosting. There we go. And who here knows how to turn off this window in Zoom? I love that we're recording. There we go. Awesome. Hi, folks. My name's Randolph. Today, we're going to talk about databases and the 21st century, and the fact that the 21st century has been around for 21 years already. And the fact that not much has changed, even though we're dealing with SQL Server 2019 and big data clusters and Linux and all those other things. As Chad said, I've done a bunch of stuff. Actor, consultant, chocolate fiend, MVP. I also happen to be on the advisory committee the advisory board. I have to get this right. The advisory board for the Azure Data Community and the advisory committee for Data Saturdays. Plus, I am also the group leader of the Calgary user group, and I co-wrote 3 books. So yes, I've been busy, but I don't sleep. That's the secret. The important thing on this slide is my email address. Everything else is secondary. If you want to ask me a question about SQL Server, or a question about the book, or even my acting career, more's the pity if you do that, but please feel free to reach out on my email address that you can see there, and ask me anything about SQL Server and maybe Fargo, because I was on that show. So here's the fun part. What does a database administrator do? You'll notice that I've highlighted a couple of words here and there in this slideshow, and the reason for that is because I'm drawing your attention to them. That's why highlights were invented. And I'm highlighting the term database administrator, because I'm sure you've heard the term data professional instead. And that's because a DBA isn't a DBA anymore. You have to know a whole bunch of stuff. That's one of the reasons you're here today, and that's what I'm going to talk to you about. What does a data professional do? And by changing the point of view from being an administrator of databases, like a production DBA who does backups and maintenance tasks all day, to a data professional, somebody who understands data. And that could be anybody from a production DBA type job to a data scientist. There's a lot in between. And it's incumbent on us to keep up with technology as we move along and try and see what's new and what's relevant and keep on top of things. And that's hard to do. I need to move some stuff out of the way here. So let's see if I can do that. Hide floating panel. There we go. Now I can see everything on my screen. What does a database professional do? I already spoke about production DBA stuff. You've got to install, upgrade, migrate, configure. You've got to be able to do capacity and resource planning because, as I've just been struggling with today, I have dug myself into a hole that was created 8 years ago by storing audit data that didn't need to be stored. So now we have almost 60 million rows of data, of XML data, that we need to get rid of because we're running out of space. And we didn't need to store it in the first place. So 8 years ago, the Randolph of then is embarrassed about not planning correctly. That's just one aspect of the job. We've also got to know how to modify data structures, and we spoke about this before the session started. How do you tune queries? How do you make things go faster? That's just part of the job of being a data professional. Modifying data structures means not just creating indexes and modifying tables and queries, but it also means modifying views. Maybe you've got to change data processes that are coming in, or you're exporting to a Kafka process. So there's a lot of stuff that you got to think about there as well. And then my favorite thing, which nobody ever thinks about until it's too late, managing security, whether that be compliance, whether it be data security itself, like TDE, whether it be user security, so in-flight security, like I've forgotten what the thing is called. Somebody jump on the call and tell me. I know one of the smart people will. do.
Always encrypted?
That's the one. Thank you. I can remember writing the chapter in the book. I just couldn't remember what it was called. So the other stuff, and this is over 2 pages because when I originally wrote this out, it was hard to read. So that was page 1, and this is page 2. You've also got to know how to manage high availability and disaster recovery. Now, I've put this on page 2, but technically that's page 1. That is the fundamental task of any DBA is disaster recovery. You've also got to know how to query data for reporting and analysis. And this is slightly different to what I spoke about before of tuning queries. This one is about creating queries so that you can support the business. The whole point of you being there is to support the business and help them achieve their goals in the best way possible. And now, because we're now data professionals instead of just DBAs, we've got something called what Microsoft calls the data estate. It's everything to do with data. You've got data in your phone. You've got data in your car. More is the pity there. You've got data in a microwave oven, in a fridge. Do you really need to worry about that kind of stuff? Maybe not. But in your organization, you need to worry about phone systems. You need to worry about print servers. Don't get me started on those, as well as just the databases, the SharePoints, all the content management stuff. So I was just reading the chat. That's not related to this. And then, of course, again, right at the end, not because it's the least important, but it's the most important. You need to know how to speak to people. DBAs traditionally, in my experience anyway, have been familiar with the word no. They love to tell people no because it's not a good idea, but they never tell people why. And another favorite is it depends without giving a reason. One of the attendees of this talk and I are currently attending some training apart from this where we are hearing stories about customers that didn't understand things either because they weren't talking to different departments or because they don't have other departments to talk to and they're just in charge of everything and they don't have time to speak to people. You need to be able to deal with folks, not just to say yes and accede to their requests, but to tell them no in a nice way and explain why things are the way they are. dealing with customers is one of the most important, they call them soft skills, but I would say any skill for a technical person. If you don't know how to speak to people, maybe you shouldn't be doing tech. And I know what that sounds like, but there are ways to learn how to speak to people, so don't worry about that. As with any skill, it's something to learn. For example, did you know that I had to learn how to speak to people? Did you know I had to learn how to look people in the eye? Because I have a neurodiverse condition, which when I was born didn't allow me to speak to people directly. I was very shy. So it's a learned skill. Theater was part of that. That's why I act. So we spoke about what a data professional does. Now we need to speak about data professionals' knowledge. So you need to know how to do all those things that you're supposed to do. That means all the stuff from the previous slides. Plus, you also need to know relational theory. Now that sounds scary. Like, do you really need to know what COD's principles of relational design are? No, you don't. But you do need to know how foreign key relationships work. You need to know about joins. You need to know about inner joins. You need to know about matches, like hash matches and stuff like that. You need to understand how data relates to each other, the set theory. For example, SQL Server is very good at returning data in sets, but not row by row. So if you understand that kind of stuff, it's a lot easier for you to help your customers. And by customers, I mean people you work with internally as well as externally. You need to know about database queries. I mentioned this on a previous slide as well, but database queries are not just tuning them, but also understanding what they're trying to do. Because you might have to rewrite something, you might have to inherit code from somebody who is no longer there with zero documentation. And by virtue of that, you also need to know the internals. What is a data page? What is an index page? What is the difference between a clustered index and a non-clustered index? You don't have to know everything, but it's very useful. And the previous discussion as well alludes to this. We spoke about CDC, or change data capture. What is it actually doing under the covers? It's reading the log file. So you need to watch your IO subsystem, your storage subsystem, to know that that could be a fundamental impact on your environment. So knowing internals is, you don't have to know it to the degree of a Paul Randall or a Kimberly Tripp or me, but it does help if you know how a data structure is stored and how stuff happens on the internals. Do we have any questions at this point? If you do, please just jump in off mute because I can't see the videos. Or if not, I'll just continue.
I have a quick question, and so I'm sorry, I'm going to ask. You mentioned that you had to learn how to talk to people, how to look them in the eye. Do you have any suggestions for people that are working on that or trying to do that? Any like exercises or something they could do? And I know that's slightly off topic, but I still think it's important as a database
very
person.
good question. I appreciate that. So for me, because I can only speak about my own experiences, I socialized in ways that forced me to learn those skills. So I did theater. I also joined a choir, and these are ways to have fun with people without actually, just being around them, like a book club or stuff like that. You can even you can go on walks with people. Like there's a walking club in the town where I grew up, where people just walk around a lake and then go home. It's a big lake. It takes about an hour to get around. But then you start talking to people, and as you become more comfortable with people, you start learning how to open up to them. And the thing about being a technical person is that we like to be involved in the keyboard, the screen. I'm talking to you through the magic of technology, right? But we do miss that social connection. So you need to practice it. It's like any other skill. You need to practice it. I hope that answers your question. If it doesn't, we can take it offline and
Yeah.
you can email me about it.
That helps a lot. And Jonathan commented back that he plays D&D to help with his.
So any sort of close-knit social environment where you are forced to communicate with people outside of your work, because that's, in a work environment, you've got a whole bunch of stressors and stuff like that. So you want to try and eliminate that. And if you're socializing with people from work and no one else, that's also something that you should consider working on. Because if you live and work with the same people, you're going to end up in each other's hair, you're going to get upset with them, and you're not going to be able to distance yourself from them because you have to go to work, right? So definitely try and keep your social circles separate from work if you can. There's nothing wrong with socializing with people from work, but don't have those as the only people you socialize with. All right. Moving on to what else does a data professional know? You got to know SQL. I mean, that's the whole point of us being in the Microsoft Data Platform community, right? You've got to know how to write a select statement. Now, this doesn't mean you need to memorize everything. I have to go into books online every day to go and see how to write a query. Not a select query, but I understand the select goes first in the columns. For example, sometimes I forget the order of a where, order by, and an having. So if I want to count the number of aggregated values that I've got in a query, I know that I need a having clause, and then I remember, oh yeah, it has to go at the end after I've done other stuff. So you don't have to memorize everything, but it's good to know exactly how to write the query as opposed to, you know, just winging it. There's a customer I know who loves select star. Great in development, bad in production. So if you know your structured query language, your SQL stuff, you're ahead of the curve, I gotta say. Now we come to the interesting part, and that is distributed computing. It's a very scary term, but everybody uses distributed computing today. If you use Twitter, it runs on a distributed infrastructure. If you work on a client server model, like you've got your application server and your database server and your web server all separate, that's distributed computing as well. The internet and running stuff in the cloud or in mainframes, as the 70s people remember it, it's all like shared rented computers that are distributed because you've got to make sure that your load is averaged across multiple machines for disaster recovery reasons as well as availability. You've also got to know operating systems. I mean, this one's an interesting one because when I grew up, I started with something called, what was it called now? Help me out here. Oh yes, MS-DOS. Do you remember that, kids? Now, the thing about Microsoft is that everything that they write is backward compatible. There is a lot of stuff that runs on Windows today that ran on 8-bit MS-DOS, which is frightening in one way, but commendable in another way. Microsoft really cares about the experience. Then you get a different environment like Linux, which is kind of the new kid on the block because it came out in the 90s, which I know is 30 years ago. Don't hate me. But it allows the mindset of move fast and break things. Fortunately, companies like Red Hat, Canonical, and SUSE, who all offer support contracts, also have long-term releases. So that means they like the stability because they understand that customers want the stability. But you've got to know that kind of stuff. You've got to know how to traverse a file system from the command line because you may not have a mouse. You have to know if you get sat down in front of a computer that you've never seen before, it might be running AS400. It's Unix. Unless you've watched Jurassic Park, you may not know Unix at all, but it's out there. Mac OS, which is also based on a Unix kernel, is quite similar to Linux, but they're very different to Windows. Windows does things slightly differently to everyone else. So when you're switching between them, it's very easy to get confused. So one of the things that I like about Microsoft's new philosophy is embracing open source, which means that you can run Linux on top of Windows. So you don't have to find the Windows version of everything. You can now just run Windows subsystem for Linux and get the best of both worlds. And then, of course, my least favorite of everything, and not because I don't like storage, but because it's so complicated. Storage can be the bane of your existence or the answer to all your prayers, especially if you're dealing with the new stuff like NVMe and SANs that are basically flash storage arrays. It's amazing stuff, but it's all down to the latency between you and your storage layer. And a lot of stuff these days is behind a network interface of some sort, which means it's slow. And this is where we're going to get into the meat of the presentation now, is how slow is slow, or how fast is fast. But before we get there, I'm just going to ask questions. Andrea Allred has mentioned in the chat that you cannot name a file con or con because of backward compatibility. That's right. I was actually talking about that this week, coincidentally. I ran a content management system for an educational website in South Africa, and we had a naming convention of 3 characters for generating the folder structure, because Windows also has a path limit, a length of the limit of the path. So we were trying to save space, and we created one subfolder called con, C-O-N, and the entire content management system broke. We had to go back to a backup from the previous day. So yeah, that was good, and it's all because of copy con or copy console, because that's how you used to edit files in DOS. You didn't have an editor; you would copy your command from the console and be done. So there's a lot of knowledge that you can pick up. And on a side note, I'm going to digress slightly here. Somebody wrote on Twitter. I live on Twitter, in case you hadn't noticed, but somebody mentioned recently that every single job experience that you have, whether you may think so at the time, in tech is useful. Because, just for example, you can't name a file con because of backward compatibility. You now have that knowledge, so that next time you see it, you will be able to help fix the problem very quickly. You may know, for example, that certain SAN interfaces are not able to, and this is specifically for a member of the audience, certain SAN interfaces are not able to operate at higher than a certain bandwidth. So if your storage is slow, it may be the SAN. It may not be the database. But you got to know this stuff, and you pick the stuff up through experience. All right. This is my favorite question of the day. Which versions of SQL Server have you used? Now, you can answer in the chat or you can come out of mute, but I'm going to go through the versions that I've worked with, and you can say yes or no. I have worked with SQL Server 6.5. I've also worked with 7. I've worked with 2000, 2005, 2008, 2008 R2, 2012, 2014, 2016, 2017, 2019. I have not worked with big data clusters outside of a classroom environment. A lot of folks are mentioning version 7 and onwards, 6.5 and onwards. Then we've got the champion of the group, which is Ben Miller of 4.21 to 2019. Here's something interesting. When I was originally creating this presentation, I was also working on a different one for the past summit, and that was about SQL Server on Linux from the command line. And I was doing some research, and I got SQL Server 1.01a or 1.0a to install on OS2 Warp in a virtual machine. And it's all command line. I don't recommend you do that unless you have lots of time in your hands. But Ben has just confirmed that he's installed a version on OS2 Warp. So SQL Server has been around for a long time. So how are we expected to remember everything that changes? That's a good question. Glad you asked it. Fortunately, Microsoft, even though they lay claim to the best backward compatibility in the industry, they also say, well, at a certain point, and that point happens to be 10 years or close to 10 years for every product, they no longer support it. So although we've got people here who have worked with even before 6.5 and all the way through to the new stuff. TJ, thank you for joining and disrupting the session even in the chat. TJ, we're talking about which versions have you used? So Ben is the oldest person here in terms of experience, 4.21 And I was just curious what versions you've used. I think you've been around for a while. Yes, Chad. The disruption is recorded for all eternity. So Microsoft have said, well, after 10 years of a product being around, we're just going to stop supporting it. It doesn't mean it doesn't work. It just means if there's a security patch or some sort of bug, they're never going to fix it. And there have been exceptions to that over the years. For example, did you know that Microsoft SQL Server 6.5 and Microsoft SQL Server 2000 are still under extended support for some customers? So every 10 years, well, 10 years after a product has been released, Microsoft discontinues support for it. So that means even though we have all this knowledge, we're only meant to support since 2012, which is great because in the old days, there used to be like 5 years between versions, but now there's 2 or even 1 in the case of 2016, 2017. How are you supposed to keep up? Do you know how many times I've heard in the training just from this week that I'm on where the presenters don't remember which version a feature was introduced because it may have been 2016, it may have been 2012, it may have been 08 R2, it may have been 2019. It's just so hard to keep up. Fortunately, again, Microsoft adds stuff. They've stopped taking stuff away. I wrote a blog post a few months ago about deprecated features in SQL Server and discontinued features in SQL Server by version since 2012. And the reason I did that is because Microsoft said when 2016 came out, we are no longer going to be, I'm going to rephrase that. When 2016 came out, they said, we're keeping database mirroring in the product, but we're not going to add anything to it. We're not going to do anything else to it. It's deprecated. In other words, use it, but it's not technically supported. But because of 2017 coming out so quickly and 2019 coming out so quickly, they realized that DB mirroring, database mirroring is still in the product. It's never going to go away. So you can continue using it. And some people might find it superior to high availability stuff like availability groups because that is more complicated to set up. So when you're looking at these different versions, I can completely understand why, even though there's a whole bunch of new stuff coming out every year, every 9 months in some cases, it's okay because you're probably not running the latest stuff when it comes out. So the second part to my question would be, how many folks are still running an old version of SQL Server? And by old, I mean unsupported. So anything older than 2012. Answers in the chat. Yep, there's one at least. Yeah, a lot of folks are in 2008 still. 2008, 2008 R2. Not much changed in the database engine per se, but 2008 seems to be the oldest version that's still being used today. And my sympathies. And there's not much you can do about it. You just have to make sure it keeps on trucking. Got to isolate it from all the security risks that are available and all that kind of stuff. Got to run it on an old operating system because even though it does run on 2019, so that's Windows Server 2019, it does run on there, but it's work to get it set up. Yeah, there's somebody's just posted in the chat the 2008 R2 SP3 GDR. So they're on the GDR stream, which means it's security fixes only. And that build date was 2017. So the last time SQL Server was updated was for a security patch, 2008. And yep, my sympathies. .NET 6.3, which is, I want to say 2008 R2, Windows 2008 R2, I think. But that's the other thing. You've got to run this on an old operating system that's no longer supported. That's also tricky. Man, there's a lot to keep in mind, right? And then there's Azure SQL Database. How many folks in the room have never used Azure SQL Database? And if nobody answers, oh, there we go. I was going to say if nobody answers, then I'd be saying you're lying because you don't have to move over to the cloud just yet. We're going to talk about that. You don't have to move over to the cloud. That's where everybody seems to be going, but that's what they said about mainframes back in the day. It's okay if you're not in the cloud. It's okay if you don't know Linux. It's okay if you've never heard of, let alone seen a managed instance. It's okay if you don't know what a container is. It's okay if you don't know how to pronounce Kubernetes. It's okay. And the reason it's okay is because it's all the same stuff under the covers. It really is. It's just SQL Server. And if you use SQL Server in 2008, 2008 R2 today, all of the features that were introduced in 2008 and 2008 R2 are still in the product. And if you have a need to continue being on SQL Server 2008 and 2008 R2, Microsoft will support you if you do it in Azure. Did you know that? Microsoft will allow you to use SQL Server 2008, 2008 R2 in Azure on a VM if you need it. Supported. Isn't that great? I think it's great. It's just SQL Server. That's the point. Now, previously I said we're going to get into the meat of the conversation, and that's going to be about time. How do you measure time? This number is boggling. There are 1 billion nanoseconds in 1 second. Why do I talk about nanoseconds? Because CPU clock speed is measured in nanoseconds. How much is a nanosecond? If I tell you there's 1 billion nanoseconds in 1 second, that doesn't mean anything to you. It's completely meaningless because our brains don't comprehend that kind of scale. They don't. For example, did you know that the average human being lives only 2.2 billion seconds? But what does that mean? Well, that's 70 mumble years. But if you hear a number that big, you can't relate it to anything. So that's what we're going to do now, and why I'm going to show to you that even if you haven't worked with the new stuff, it doesn't matter because it'll hold you in good stead going forward. So here's a graph that I love to present, and the whole premise here was to show you CPU clock speed on the left here, 0.4 nanoseconds for a 4 gigahertz CPU. 4 gigahertz CPU means that the clock ticks over once every 0.4 nanoseconds. But the scale in this is so out of whack that even at 100,000 nanoseconds for SSDs here, for one cycle in a SSD, it's still only a tiny, tiny line in relation to a hard drive latency and a ping between Salt Lake City and Denver. So if you do a network ping, the average network ping time is 11 milliseconds. 11 milliseconds is still a whole bunch of zeros. In fact, it's closer to 12 milliseconds. So in relation to network speed and hard drives, this chart is meaningless. But I wanted to show it to you how meaningless these numbers are by removing some of the stuff. So now here I've removed hard drives. So I'm going to go back again. So on this one here, we've got hard drives and the ping time, and SSD is the only line that you can see on the chart. And then I'm going to go to the next one, which shows SSD. That's that same number, 100,000. That was just a line on the previous graph in relation to NVMe, in relation to Optane, in relation to Optane PMEM, which is a different type of storage, which we'll get into later in the presentation. But even at this scale, with 100,000 here and 0.4, you cannot see the difference between 0.4 and 350 nanosecond latency. This is just mind-boggling. There's no other way to describe this. So how do we scale this in a way that is more understandable to a human being? And the way we do that is we relate a CPU clock speed to 1 second. So every time that the clock ticks over in a CPU, instead of being 4 gigahertz, which means 4 billion times per second, what we're going to do is we're going to say the clock now runs at 1 hertz, or in other words, 1 second. So if the CPU cycle, instead of being 0.4 nanoseconds, is now 1 second, we've now got a very, very different perspective of how latencies affect us. So we've got level 1 cache access. Level 1 is a tiny piece of memory on the CPU die. So your CPU is a physical substrate of silicon and other fun stuff. And the CPU itself is just a bunch of on and off switches, a bunch, like millions and billions of switches. And then there is a tiny bit of memory on the die itself. There's in fact 3 layers, sometimes 4, called level 1, level 2, level 3, because we're good at naming stuff. So level 1 cache is the closest to the CPU itself, and accessing the L1 cache takes 0.9 nanoseconds, so about twice as long as a clock speed tick. So in other words, 2 seconds versus the 1 second for the clock speed. And then here comes your first mind-blowing experience. Memory, like regular RAM, takes 4 minutes. If a clock ticks over every second, it takes 4 minutes to access any data from physical memory. 4 minutes. Now we go to storage layer, and the fastest storage that is not PMEM, we'll talk about PMEM later, the fastest storage currently is NVMe. NVMe is a 25 microsecond latency, which by our scale is 17 hours. 17 hours is almost a day compared to 1 second. This is just, Chad has said, boy, can you imagine, I'll get that 64K disk read back Sunday afternoon and my ping will come back next April. That is exactly what I'm trying to convey to you. Nothing else matters when your storage is slow. Nothing else matters when your network is slow, because you can have the slowest CPU on the block, but if you've got a bottleneck somewhere else, and in the cloud it's always the network, if you've got a bottleneck somewhere else, it doesn't matter how fast your CPU is. And this is the kind of scale that you need to appreciate to understand why you have the knowledge that you think you need for the future stuff, because this applies everywhere. We're going to just jump through this quickly. An SSD, a regular SSD, 3 days compared to 17 hours. LAN, local network, 1 millisecond is now a month versus a second. And then, of course, my prime example was the Salt Lake City to Denver ping time of 12 milliseconds is a year. 1 second, almost a day, and then a year for the different scales. Any questions before I move on? All good, moving on. So let's talk about the CPU. What is a CPU? Well, it stands for Central Processing Unit. And I mentioned this earlier, it's just a bunch of on and off switches. A CPU, for all intents and purposes, doesn't have any brain or thinking or logic attached to it. It uses logic gates because that's the kind of technology that it allows electrons to move through, but it's not intelligent by itself. And in modern CPUs, they're separated out into cores. Excuse me. And the reason they're separated into cores is because of something called Moore's law, which he wasn't the CEO of Intel, but he was a senior guy at Intel, where he said that CPUs would double in performance and halve in price every 18 months to 2 years. And then we reached a limit. We reached a limit because of heating. And I'm talking to you right now on a very expensive fan made by Apple, the MacBook Pro. It's the most expensive fan I've ever owned because all I ever hear is the CPU fan. Yes, the CPU does math really fast, so it looks smart, but it isn't smart because it relies on software to make it run. So you've got your physically distinct processing units on the same die. So that's that silicon substrate that we spoke about before. Instead of being able to scale up because they just ran out of thermal room, basically, it just got too hot that when you've got your on and off switches really close to each other, they overheat. And not only does it cause them to melt, but it can also cause the electromagnetic field to change. So it would flip bits if it got too hot as well. So they've taken the substrate and they've put 2 cores on or more. Now you can get 64-way CPU cores, which is just also mind-boggling, and put them on the same substrate so they're connected to the same socket, which means that the performance is much better than if they were separate CPU sockets and have to go through the motherboard. So it's a little bit quicker to talk between them, but they're still physically distinct. And because of something called the speed of light, who thought of that thing? There is a physical limit to how fast information can travel. So they have to be as close to each other as possible. For SQL Server, single-threaded performance matters more than anything else for OLTP. So if you're building out a SQL Server machine for OLTP type databases, you will want to get something with fewer cores and higher single-threaded performance. It doesn't matter if you've got 64 cores, because SQL Server has to manage all those threads and it just slows it down. And as more threads start getting used, the temperature increases, so they have to slow down the cores to prevent overheating. So it doesn't make sense to spend all this money on SQL Server licensing, which at last time I checked was 8-something thousand for Enterprise Edition per core with a minimum of 4 cores. You don't want to get a 64-way CPU and then have to spend all that money on those core licenses if you're not going to use them. So if you're speccing out an OLTP style database server, you will focus your attention on higher single-threaded performance with fewer cores. Glenn Berry has a website called sqlperformance.com, I think is correct, and he goes through all the latest CPUs that are out there. He's looking currently at the AMD stuff and a couple of new Intel chips, and he will tell you if they're good or bad and whether they're appropriate for OLTP, which stands for Online Transactional Processing, if you don't know, and that's okay. It just means lots of small transactions. If you're doing stuff like data warehousing or reporting style queries or analysis, then your single-threaded performance doesn't matter as much. What you care there about is parallel processing. So then you want as beefy machines as you can get. But for transactional stuff, you want high single-thread performance. And I mention this here because in SQL Server 2016, you now have a new setting in the installation process on Windows where you can set the maximum degree of parallelism. Ben has just posted a link to Glenn's, so it's Glenn's SQL Performance, thank you, .com. So in SQL Server Setup on Windows, you now get the option to set your maximum degree of parallelism when you install SQL Server, which is a lot better than it was in previous versions because it would be set to 0, which was the default. The problem with the default is SQL Server is designed to use all the cores if your max degree of parallelism is set to 0. And if you've got a 64-way machine, it's not going to perform well. It's going to be horrible because your maximum degree of parallelism depends on a bunch of stuff, and those bunch of stuffs recommend that you set it to 8 or 16, depending on the kind of NUMA configuration you have. And we'll get into NUMA if you want to. NUMA stands for the type of memory allocation that is on the motherboard. So on the old days, you would have 1 or 2 sockets, and then you would have 1 bank of memory. With NUMA, which stands for non-uniform memory allocation, you have multiple banks of memory, so 1 for each socket. And that means there's less distance between the memory, and it doesn't have to share it across all the sockets. So NUMA is better for multi-socket machines. And depending on the NUMA configuration of your environment, maximum degree of parallelism tells SQL Server how many CPU cores it can have available to run a parallel query. What you don't want to do is run a parallel query across all of your cores and then have other small queries that just can't get time on the CPU. So that's why you want to also limit your maximum degree of parallelism. Before I move on, are there any questions about that? It's an old speaking trick to say, are there any questions, so I can drink a glass of water there. So pause for effect, but also to say, how many folks here think that hyperthreading is a second core, because it's not. Hyperthreading is the Intel trademark for this technology, which is called SMT, or simultaneous multi-threading. I call it symmetrical multi-threading as well. Basically, it means being able to use more than one process on the same physical core separated into a logical core. So what hyperthreading is basically a little bit of extra headroom on top of your physical core. It is not the equivalent to additional cores. If you want 2 cores, you need to buy 2 physical cores. You will not get 2 cores if you have a single hyperthreaded core, because it isn't a full CPU core. The performance profile just isn't there. Hyperthreading adds at most 15% additional headroom to your query performance if you turn it on. Now, the reason I say consider virtualization there is because if you set up a virtual machine on a host where you don't have insight into the physical cores, you could end up, for example, on an 8-core physical host with hyperthreading enabled. You may think you have 16 cores, and so you set your SQL Server to run with 16 cores. And then the performance is horrible, and you don't know why. And the reason is this: hyperthreading is not free CPU except for that little 15% headroom. Glenn's blog posts will tell you about this, but AMD has caught up to Intel. Ryzen CPUs are really, really good and really inexpensive. In fact, they've gotten so good that Microsoft stopped offering their, I think it was 3-for-2 license deal that they had. At one point, if you were running on AMD, you could get a discount on your license fee because AMD wasn't that great, but that has changed dramatically. In fact, I would say that Intel is not long for this world on the desktop server market if they don't do something radically different in the near future. We mentioned this as well in the beginning before the recording started. We were talking about ways to improve performance. Turn off power saving. This can be done at 2 different levels, or 3 if you're in a virtual machine. You need to turn it off at the BIOS level, so the hardware level, before you turn on the operating system. You need to turn off power saving, and then you need to turn it off at the host's operating system, and then you also need to turn it off at the guest's operating system level. Power saving is good for saving the trees, but if you're spending $9,000 per license on a SQL Server Enterprise Edition and the CPU only ramps up after the query is finished, you're not getting your money's worth. So make sure that if you're running a SQL Server environment, that you are getting your money's worth and turning off power saving settings. I have a question here from Chad. Are hyperthreading, the CPU feature, and multi-threading, creating 16 virtual CPUs in a VM and assigning 8 physical cores from the host, kind of similar in performance, or are they different? Chad, they are the same thing, basically. So if you assign 8 physical cores in your VM from the host, then it's the same thing as using them directly on the physical host. So yeah, you're good to go there. What I was guarding against in that previous slide here is to say, don't think that a hyperthreading core is the same as a physical core. So don't try and think that you're getting more bang for your buck. Don't over provision. Any questions about CPU? Because now we're going to be moving on to the next section. And I just want to do a time check. I think we're at 45 minutes, right?
Yes, we're at 45 minutes right now.
Thank you. So let's talk about memory. Random access memory, RAM. Remember that graph that I showed you where it will take 4 minutes versus 1 second to get some RAM? RAM's important, and it is the fastest component of your subsystem behind the CPU, and the one that's the most important for SQL Server, because if 1 second versus 4 minutes, if the gap between CPU and memory is that big, you know it's even bigger from memory to disk, and I showed that to you. So SQL Server makes use of memory as much as it can. And it does that with a setting called max server memory. The default is 2.1 petabytes. How much is a petabyte? It's a bunch. That's the technical term. It's a whole bunch. Your max server memory is designed to use all the memory in the system. That's just the bottom line. If you have a machine that runs Windows, and I'm going to talk about Linux later, as you can see on the slide there, if you set your max server memory to 2.1 petabytes, which is the default before 2016, you will ultimately run out of memory for Windows. That's just going to happen, especially if you have more memory. I have a blog post, which is actually not a blog post anymore. It's just a physical page, bornsql.ca/memory, where it recommends, based on Jonathan Cahias from SQL Skills. Jonathan Cahias has a formula that he created, which is kind of the same but better, in my opinion, and it's my opinion, than the Microsoft recommendation for setting max server memory. The problem comes down to the fact that Windows also needs memory to run. It needs memory for drivers. It needs memory for threads. It needs memory for other applications on your server. How many folks here run Windows Core? No, you've got a graphical user interface. Most people use the graphical user interface, which needs memory. You've got, please tell me you don't use, Ben Miller loves Windows Core. Ben, a party of one there, because not a lot of people like Core. And the problem, and Chad's just put a frown face there, the problem with Core is that you need to know how to use PowerShell or some sort of command line interface, because people are used to clicking. And that's not a bad thing, because if a computer is easier to use, more people will use them. Long live PowerShell, sure, but not everybody knows PowerShell. So you've got, and what I was going to say before these chats came in, please don't tell me you use Google Chrome on your server, because if you use Google Chrome, it will use more memory than SQL Server if you ask it to. It really will. It's horrific for memory usage. Why? Because Google had the same philosophy as Microsoft did. Hey, if it's in memory, it's going to be faster, right? So applications are going to fight to use memory. You've got to make sure that your physical memory, Google Chrome with Gmail open is even worse. Yes, thank you, Chad. That is true. Why? Because memory makes things faster, because of that huge time difference between the CPU and memory access. So you've got to give some of that memory back. Otherwise, SQL will use it. And what happens, and this happens on Windows, is Windows will blue screen. First what will happen is that things will start failing randomly. Drivers will fail, especially badly written drivers. And unfortunately, there's a lot of those, especially if you have a third-party motherboard provider or stuff like that. Drivers are the first to go. They're horrible. Storage layer is the second thing to go. Then your network's going to fail. And then suddenly Windows is going to blue screen. And why? Because it ran out of memory. It didn't have enough threads to do what it needed to do. It didn't have enough contiguous areas of memory to be able to do stuff. So what you want to do on Windows especially is reduce the amount of memory that SQL Server has access to, assuming you're using Enterprise Edition and you don't have the artificial limit there anyway. So you've got to reduce your SQL Server memory limit to a reasonable amount, and Jonathan Cahias' formula you can use. You can also use the one that Pedro Lopes and the other folks at the Tiger Toolbox team on GitHub. I don't have the link on hand immediately, but there's a bunch of scripts that are available from the Tiger team, which is the old name of the SQL Server team. And they produced a bunch of scripts for you to do maintenance tasks and so on. And they also have recommendations on configuring your max server memory. Jonathan's formula is, I think, better because it gives more memory back to SQL Server, but the other one's just as good. What you don't want to do is say, well, I only need 4 gigs for memory for Windows and I need 96 for SQL Server. Just don't do that. I've said here that the max server memory limit does not apply to column store or in-memory objects. So in-memory OLTP is a relatively new feature for SQL Server, as is column store. They have their own memory allocations, and you have to be very careful here, especially if you're using standard edition, that you can use these features, but they are limited. And the limits are small. You've got 32 gigs of RAM available per database for column store. And for in-memory stuff, it's for the entire instance if you're using standard edition. And once you reach that limit, excuse the profanity, but shit goes bad. It's horrible. So if you're using column store or in-memory, because you're trying to get around that max server memory limit in standard edition, you've got to watch it like a hawk. So please be careful with memory management. Now we're going to talk about Linux now. I know a lot of folks are not using Linux. I know that for a fact because I don't get a lot of support calls for it. And you don't hear a lot about it. It is out there. It is a significant enough number of people for Microsoft to keep putting it out there, but it's not big enough that it affects our daily life. But if you are using Linux and you're running SQL Server on Linux, you don't have to change your max server memory setting if you leave the physical allocation to the default of 80%. What I mean is Linux is a different operating system to Windows. It works differently. So when you have a process that uses more than 80% of physical memory, the kernel says, well, I need to save myself, so I'm just going to kill that process. And it's not going to ask. It's just going to kill it. SQL Server doesn't like a disgraceful shutdown, or an ungraceful shutdown, I guess is a better way of putting that. It doesn't like being killed because there's a whole bunch of stuff that happens when it comes back for crash recovery, and you don't want that. So if you have SQL Server on Linux, the default physical memory setting is already automatically configured to 80% of physical memory. In other words, you don't have to change max server memory on Linux if you don't change that other setting. That's good to know, I think. And as I mentioned before, SQL Server 2016 and higher, you've now got on Windows the max server memory option in your SQL Server setup. The reason I don't say Linux here is because Linux is installed slightly differently on Windows. It takes 2 minutes to install the database engine on Linux. It takes 20 minutes on Windows. Go figure. Any questions about this page? Or I can just move on. All good. Ben has put the link to the Tiger Toolbox GitHub repository there. Even though they're not called Tiger Team anymore, the scripts are being updated fairly regularly and they're taking pull requests from the community. So it is still being maintained. My favorite fact about memory is that background cosmic radiation will change your data in memory unless you use ECC RAM. And a rule of thumb is if you have a laptop with more than 16 gigs of RAM, you need ECC RAM for that laptop because of the density of the RAM on the physical interface is such that the RAM itself can be flipped on and off by background cosmic radiation. So if you use SQL Server, you need to use ECC RAM. It's just a good practice. ECC RAM isn't as expensive as it used to be. And I would always say, if you can afford it, get more RAM before you get more cores. Absolutely. SQL Server loves memory, so give it to it. Now we're going to talk a little bit about lock pages in memory, which is a policy. It's an Active Directory policy as opposed to a configuration in SQL Server itself. This is one of the two policies in Active Directory that we talk about in SQL Server. The other one is instant file initialization, which allows SQL Server to instantly grow data files. It doesn't apply to log files, but it does to data files. We'll talk about that later. But this is another one that we talk about, and that's lock pages in memory. If you are running a virtual machine on a shared host, in other words, noisy neighbors and stuff like that, you don't have control of the other machines on you don't have control of other virtual machines on that host, then do not use lock pages in memory, because what it tries to do is allocate a fixed amount of memory, physical memory on the hardware. And if something else tries to get that memory, it doesn't allow it, and it causes untold chaos. So if you're using lock pages in memory, my advice would be to do it only on physical hardware, or if you're virtualizing SQL Server, that you can manage it carefully. So let's talk about storage. We had our CPU, we had our memory, and now we're talking about where we store our data. Obviously, faster is better, because NVMe was, what was it? I don't remember now. A ridiculous amount of time compared to the CPU. But everything else is even slower. Like solid state is 100,000 nanoseconds versus half a nanosecond for a CPU clock cycle. Solid state drives eliminate seek time, rotational seek that was introduced by having a moving disk. So the read head on the disk, and the write head as well, but the read head would need to spin the surface of the disk, and then it would also move the arm over the surface to find the right place on the disk. And the outside of the disk moves faster just due to rotational science. So it moves faster on the outside. So you always wanted your data on the outside and blah, blah, blah. So that seek time added up. And that seek time is significant. It's in milliseconds. A millisecond is a very big number in hardware. So solid state removes that seek time, which means that solid state is faster by design, but it's still not fast enough for SQL Server to take advantage of it unless you're using NVMe and other types. So when you install SQL Server on new hardware, you need to test the performance. And you want to test the performance in terms of IOPS, or input output per second, with a large block size. SQL Server uses 64K extents, and now I was in training today and we spoke about this a little bit back and forth. The hardware vendor matters. So if the hardware vendor is a storage array from Pure Storage, Argenis Fernandez is going to say you need to have a 2 megabyte block size for your data files and your log files. But you don't want to put other stuff on there, because then you run out of space really quickly, because even a 4 kilobyte file is going to be 2 megs of storage. So you have to be careful there. But you want to test IOPS with a large block size, because SQL Server uses large block sizes. And then something called drive queue depth is as important as IOPS. So you may have a very flashy ad on newegg.com or whatever that says, yeah, we've got 50,000 or 100,000 or 300,000 IOPS, but then the drive queue depth is very low. The drive queue depth is how much it can store in the queue before it starts getting slow. I'm dumbing it down extremely there, but that's basically the point, is you want a large queue depth so that it can queue a whole bunch of operations against the storage layer and just be faster. I've put this at the end here. Malware detection is the enemy. What I mean is, if you've got an antivirus, it's okay if you've got an antivirus or anti-malware or Windows Defender, which is built into 2016 and higher, or whatever it's called this week. But you want to exclude SQL Server from your malware detection, because SQL Server has a very particular usage pattern of the storage layer, because it manages its own stuff. So I'm just going to go back to this previous slide here. It's a previous point. Where can I learn more about drive queue depth? Ben has just answered. You can use the keywords disk queue length. The reason for that semantic difference is because I wrote a book for Microsoft Press, and Microsoft does not like calling them disks. You have to call them drives. So I've just gone and adopted that because it's just easier. Disk queue length is the right way to search for drive queue depth, but it's the same thing. Semantics, but it's an important distinction in terms of the syntax. So thank you for asking that question, and thanks for the answer, Ben. So malware detection comes down to excluding SQL Server, the service itself, so the EXE, all the DLLs, the error log location, the trace file location, the data files, the log files I've mentioned, you need to exclude all of those. There is guidance on Microsoft's website for how to do that. And it's very easy to find in your favorite search engine, unless it's Bing. And, oh, I shouldn't have said that because it's being recorded. It's very easy to find in all search engines, promise, how to disable malware detection if you have SQL Server installed. You can have it for everything else, but you do need to disable it on SQL Server. And it has a factor of impact in the order of thousands of times slower. So if you have an antivirus installed and you don't know why your storage is slow, it could be because of that. Persisted storage 2 of 2. I use the term persisted storage because there's a whole bunch of ways that you can store data these days, but persisted means it's hardened somewhere. So when you turn the device off and turn it back on again, it'll still be there. That's what persisted means. There is technology out there called HCI, which is basically a SAN in a box. So you've got your CPU, you've got your memory, you've got your storage, which are all in different nodes, but they're all in the same sort of integrated environment. There's a lot of hyperconverged infrastructure out there. There's Azure Stack as well, which is Microsoft getting on the bandwagon. The problem with HCI, Ben's just put a post to the how to choose antivirus software to run on SQL Server. Thanks. So HCI is fine. There's nothing wrong with HCI as long as you configure it correctly. What you have to keep in mind is that you're going to use the same CPUs that you currently use for SQL Server. Those same CPUs also have to drive the storage layer. If you're used to running on a single server with everything's internal anyway, it's no different. But if you're trying to save money by not using a flash storage array, for example, and you decide to put everything together, you need to keep in mind that your CPU is going to be used for storage as well. So that could cause a bottleneck. Now, we did speak about the fact that CPU is the least thing you need to worry about with storage compared to the performance profiles, but when your CPU is running the storage, it does matter. So just keep that in mind. Sorry, I heard something in the other room. Persistent memory, PMEM, is a new feature to 2017 on Windows and 2017 and 2019 on Linux and Windows for extending. Let me think about it this way. On SQL Server, you have your storage layer. So SQL Server has the buffer pool, which is where it stores everything in memory in 8 kilobyte pages. This is why you need to know about internals, right? A data page is stored in memory in the buffer pool. How it gets there is it goes and does something called a paging exception or something like that. I've forgotten now because I've been distracted by my dog. Thank you, dog. So what happens is SQL Server says, hey, I need this data page. And the memory says, it's not here. So I'll have to go and fetch it. So it goes to the CPU. It says, hey, how do I get to the storage? And the CPU says, okay, well, to get to the storage layer, you have to go through this channel, and then you get there. And then 4 minutes later, your data arrives. Or 17 hours later, that was the thing. So eventually your data arrives in memory. Now, what persistent memory does is it says, let's not store data in the storage engine or the storage layer. Let's store it in memory on a persisted, basically a microchip on the same DIMMs that your memory is on. So on one side, let's say, of one side of the DIMM, you've got your memory chips, and on the other side of the same physical DIMM, you've got your storage, your SSD. So it's still slower, but because it's right there next to the memory, how it works is instead of accessing the storage layer, you access the memory using memory copy commands. So the CPU and the memory work together to just assume that it's always in memory. And what the SSD does for that PMEM is it keeps a copy if power goes away. So the data is not actually stored in the SSD that is attached to the DIMMs. It is in memory, and it has its independent power supply. So if something happens to the rest of the environment, like the server loses power, Everything that is stored in the memory DIMM is then copied into the PMEM storage layer. And then when the server starts up again, it pushes everything back from that into memory again, so that you can start accessing it from memory directly again. So what you're doing there is you're bypassing the storage layer completely. But of course, because it uses DIMMs and because memory is more expensive than storage, it can be very pricey. But it's a very cool feature if you want really good performance for SQL Server and you've got a lot of small transactions, like let's say you're running a gambling environment, especially during a pandemic. There's also something called the buffer pool extension, which I don't really mention because buffer pool extension is for standard edition folks, I guess. It uses storage instead of, it uses SSD instead of memory to store stuff in the buffer pool, but it's slow. It's not going to be much faster than any other features in SQL Server. I don't see a lot of use for it. But persistent memory, that's cool. Any questions about storage before we move on to network? I just want to do a time check. So we're at 65, so I got 10 minutes left. No questions? Cool. Let's talk about the network. I used a clip art there to signify that the network is wireless, because generally speaking it is. I do have a hardwired network connection in my home to get to the internet, which I'm not using today. But we use these, right? Cell phones, they're all wireless. Latency is your enemy with the network. It used to be that storage was slow, and now if you want to know what's really slow, it's the network. I keep referring back to the training session that I've been in this week. One of the things we spoke about is Microsoft's recommended latency for storage. It depends on the hardware vendor. It depends on your performance profile of your environment. It depends on a bunch of things. Do you really need 10 millisecond throughput on your storage layer to get your CRM system that only one person uses to be performant? No, you don't. But if you are doing a lot of transactional processing, you want your storage layer to be as fast as possible, because SQL Server has to log everything that it does, and it logs everything before you see the result. So you need to make sure that your transaction log file is on the fastest possible storage that you have. TempDB and transaction logs should be on the fastest storage you can afford. I joke here about, why am I talking about storage in a network section? Well, it's because if you're using the cloud, you're using network attached storage. If you're using a SAN, you're using network attached storage. So your bottleneck is usually going to be the network if you're using storage that is not physically attached to your hardware. Latency is your enemy. If your application layer is in Chicago and your database server is in Salt Lake City, you've got the speed of light to contend with. I remember on one of the mailing lists that I'm a member of, it was last year or the year before, somebody said, I don't know why, but the return ping time from, I don't remember the locations, but he was talking about around the entire planet, was 200 milliseconds. How do I get it faster? Without understanding that that is a physical limit of the speed of light. The speed of light in a vacuum is a certain speed. The speed of light through fiber optic cable is reduced, so it's going to be slower. You cannot get faster than the speed of light. Of course, people try and fake that out with federated servers, so they shard out their servers. They do, what's it called? Delayed durability. I've forgotten what the terminology is, but because I don't care, because it's horrible if you're writing a database. Eventually consistent, that was it. So they fake you. So if you're using SQL, if you're using Facebook, for example, and you do a post, you'll see the post straight away. Everybody who's on the same network segment as you will see the post straight away. And eventually, it may be in the order of milliseconds or microseconds or seconds. Everybody else will eventually see the same data. It's not persisted immediately, not like the ACID compliance that SQL Server requires. So latency is your enemy anytime you're talking about network. And most people are talking about network with application, websites, all that kind of stuff. Then, of course, you've got DNS to contend with. DNS is possibly the most antiquated part of the World Wide Web today, and we rely on it. And we rely on DNS even when we don't think we are, in terms of a failover. So let's say you've got an availability group that fails over, and for some reason, the CNAME entry wasn't set up correctly, and all of your applications are pointing to the wrong endpoint. They need to switch over to the new one. And that if that time to live is set to the default of, let's say, 4 hours, it's going to take 4 hours for your application to come back up again. You've got to think about this kind of stuff in that context. Please avoid rebar, which is row by agonizing row operations. You want to do set-based operations. I spoke about this in the beginning about knowing relational theory. This is why. You got to know about the fact that network latency is slow. So you want to make sure that you set no count on when you're doing a bunch of repeated commands to your server so that it can return the data much faster. And please don't use Profiler. There's something in Management Studio 17.3 and higher. Currently 18.8 is out, so there's not really a reason that you shouldn't be using it. But if you want to use Profiler and you've got that itch to use Profiler, in the bottom of SQL Server Management Studio, there's something called XE Profiler, which is a terrible name for a very cool feature. It uses extended events instead of Profiler to give you the same information that you would expect from Profiler's two default options, the T-SQL one and the standard one. Of course, extended events is a completely separate conversation and very, very powerful. But if you reach for Profiler, use Extended Events Profiler or XE Profiler in Management Studio. And once again, everything in the network is everything in the cloud is defined by the network. Software-defined networking, but it's still networking, so it's still going to be slow. I'm going to buzz through this stuff because it's about containers. I call them virtual consumers. So a virtual machine and a container is the same thing if you're talking about virtualization. The implementation is different, yes. It means that you can fit more containers on a piece of hardware than a virtual machine because you're abstracting away from the operating system. But ultimately, they're the same thing. You're abstracting something away, whether it be for security reasons or performance reasons or deployment reasons. You're abstracting something. So that's why I call them virtual consumers. That's my term. You can use it or you don't use it. VMware is the market leader. Docker is the market leader for containers, but Hyper-V isn't going anywhere. And in fact, there's some pretty cool stuff with Hyper-V that Microsoft is doing at the moment. Kubernetes, or for short K8S, because if you take the first letter and the last letter, the K and the S, and you count the middle ones, there's 8 of them. K8S, I know I hate it too, is how you manage containers. Docker is the market leader for containers, and Kubernetes is the market leader for managing containers. If you use OpenShift, it's still Kubernetes under the covers. If you use Azure Kubernetes Service, it's still Kubernetes under the covers. It's basically a management plane for managing containers. So let's say one container goes away, the management plane will just replace it with something else, a copy of what it was, so that it maintains a state. So Kubernetes is a state management. I like that. I'm going to use that. State management tool for containers. If you have Linux knowledge, it's going to help you a great deal because containers are based on Linux. There are Windows containers. They do exist. That's all I'm going to say about that. In management, you know I'm at the end of time. I know I'm at the end of time. I'm in fact like 50 seconds over. And it doesn't matter because even though we're talking about management, this is stuff you already use. SSMS, Azure Data Studio, Command Line, SQL CMD. You may hate it, but you still use it. BCP is still the fastest way to get data in and out of SQL Server. And it runs on Windows, it runs on Linux, it runs on Mac OS. Cool. MS SQL Cli is a port of a different open source tool that is kind of sort of a replacement for SQL CMD, but it's not quite. But it does have IntelliSense, it does have autocomplete, it does have multi-line queries, it does have editing queries in line. So you open it up in a different editor. It's still the command line, but that's pretty cool. And then, of course, PowerShell. DBA Tools. DBA Tools. DBA Tools. That's how I ended my session at the past summit. I said DBA Tools like 100 times, and Chrissy Lemire was very happy. But if you want to manage more than one SQL Server instance at the same time, you do it with PowerShell. I think it was Ben who said, long live PowerShell. Yeah, he's just repeated himself. Long live PowerShell. And I've put a little star at the bottom there, cross-platform support, Windows, Linux, and Mac OS. PowerShell's support for Linux is much better than it was 2 years ago. And with DBA Tools, you've got about 75 to 80% coverage. So all of those 500 plus commandlets, about 75% of them run on Linux as well. What's not to love? And it comes built in with SMO, which runs across platform. We'll have some question time now, but I want to fly to this last slide here because this is the important thing. If you have any questions, please email me. I'll come to your question now, Chad. If you're feeling adventurous, follow me on Twitter, but please note on Twitter, I do not speak about SQL Server. You're at your on your own if you're feeling like following me there. I write a blog post every week, bornsql.ca/blog, and then this is all the copyright messages for all the images that I used. And now let's go back to questions from Chad. Chad Crawford says, a question back on the power saving setting. There were 3 places to check: the host BIOS, the VM BIOS, and Windows settings. That's not quite what I said. I said the VM operating system. Generally speaking, the BIOS is virtualized, so it'll just copy what's in the host, but that depends on the virtual hypervisor that you're using. So if you're using, and the question continues, we have some questions in AWS, and I think I'll only be able to fix the Windows setting, cross my fingers for the other 2. Does it sound right? Yes, that sounds right. However, I think I have the link open. I can't share my screen because you don't want to see what's on this screen, but I'm just going to find what it's called here. And I'm going to pop this in the chat. There are VMs that are optimized for SQL Server. So this is the link for AWS. And this is the one for SQL Server. And now these are more specific to storage, but storage is really what matters here. CPU less so. But you'll find information from both vendors about the correct compute and storage layers for your environment. So they know already how to profile SQL Server. So they have VMs that are dedicated and best used for that. For Azure, you don't want to use a B series VM when you should be using a D. You know, that kind of stuff. So that's a good question. Anything else? Feel free to come off mute. I'm actually going to quit my sharing now. And we can look at each other into the distance. Hi, folks. If you have any questions, please go ahead. Otherwise, I'll just hand over back to our hosts and we can have our regular chat.
Well, I'll say that was amazing, Randolph. That was awesome. I was particularly impressed with your memory and knowledge of the .NET versions used by old SQL Server installs. I was like, wow, that's impressive. I don't remember which one it was. You're like, I think that's .NET this. And I'm like, man, I don't even remember. I always know that you have to go install the .NET first if it's not there already. And it'll tell me which one and I'll go get it. But to have that,
Yep.
have that just to pull out of your mind was
well, this is what I said. This is what I said earlier is you pick up these little nuggets of information. It doesn't matter what your job is if you're in the tech field. I started out as a network administrator, and before that I did technical support. So I still remember the Hayes compatible commands for setting up a modem. That may not be useful now, but the other stuff I learned, like antivirus performance profiling and network latency stuff when I was setting up Exchange, that was all very useful stuff.
So for me, those little nuggets come and they go like this.
No, maybe it's
that's what happens to me.
I only need them when I need them. So yes, I may not remember that stuff until I need it, and then it's there.
Well,
And
did anybody
also, for what it's worth, if you write the stuff down and put it in your blog, then when you're searching the internet and suddenly up comes your own blog post saying, oh, yeah, remember that now.
Yeah, that's awesome.
It's your outboard brain. Yeah.
All right, last caller, are there any final questions for Randolph before we close up?
Question, is there a way we could get access to the slides?
Yes,
Specifically the chart of different latencies.
Sure. I have a PDF. It's about 2 megabytes. So as long as you don't have any, one of the things about the PASS website that really frustrated me is that they had a 1 megabyte limit for attachments. But if you're okay with a 2 meg attachment, I will send you the slides as a PDF, and absolutely feel free to share them with your colleagues and stuff like that. For me, the big clue about managing a modern infrastructure is understanding that how all the components stick together, and know that, well, if it's slow, what do I need to check, right? And Jim Richardson, who mentioned it before, like, how do you go about troubleshooting, or how do you go about performance profiling and stuff? You have to start with the hardware. You can't just say, well, I'm going to start building an index. You have to be sure that you have enough memory, and if you don't, you know how you can tune your workload, performance. Yeah. All right. There's a lot of stuff, but thank you, Dan. Thank you, TJ.
Thank you, Randolph, for your time, for your participation, your willingness to share your knowledge and experience with us. This is what makes an MVP an MVP, is their willingness to share and put out to the community, the blog posts, the forums, and here at the user group. And we really appreciate all that you've done for us and to support the community in general. We'll go ahead and close up. I'm going to stop the recording.